Good morning everyone. In this video we're going to prove all of the addition or compound formulas given that we've already proved sin A plus B equals sin A cos B plus cos A sin B. If you haven't seen that proof, watch one of my previous videos which proves sin A plus B above. So to be able to prove all of the other formulae, cos A plus B, cos A minus B, etc., we need to think about even and odd functions first. So just a really quick recap. So remember, if a function is even, f of minus x is f of x, and if a function is odd, f of minus x is minus f of x. So in particular, we have that cosine x is definitely an even function. We know that cosine x is an even function because it's symmetrical in the y-axis. So because it's symmetrical in the y-axis, you can see that f of minus x is the same y value of f of x. If I put a minus a value in there, I get the same y value out if I put an a value in. So in particular, we therefore know that for cosine x, f of minus x equals f of x. So in particular, we know that cos of minus a, if we put minus a into it, we get the same value of cosine a. That's a really important identity which we'll need to prove these. Let's also think about sine and tan. Well, sine and tan are both odd functions. Similarly, that means that for an odd function, f of minus x is minus f of x. So we'll just go straight ahead and write them. So sine of minus a must be the same as minus sine a because it's an odd function. It's got that rotational symmetry of order 2 about the origin. And just to show you here, if I put a minus a in, I get the negative y value as if I put an a in. You can see that the y values are swapped. And equally for tan, it's exactly the same. You can draw the diagram. Tan of minus a is minus tan a. So three really important identities we're going to need to help us today to prove the above formulae. These are really good to know off by heart as well. So I would kind of memorize these formulas off by heart because they are actually really useful in mathematics, in trigonometry. They come up quite a lot. So let's start with sin A plus B equals sin A cos B plus cos A sin B. Okay, and to prove sin A minus B, I'm simply going to swap the B for a minus B. That's all I'm going to do. So in this formula here, which I'll name star, I'm going to swap B for minus B. So it's going to read sin A plus minus B, which is just minus B, equals sin A, that doesn't change, cos of minus B, plus cos A, that doesn't change, and sin, I'll swap B for minus B. So there we have it. So this, if sin A plus B is true, then this formula must be true. Now I'm going to use the fact that we discussed above about cos of minus B. We know because cos is an even function that cos of minus b is just cos b, and we know that sine of minus b is actually minus sine b, and I can just tidy that up and put that minus 1 at the front there, and then we'll have our formula for sine a minus b, which is sine a cos b minus cos a sine b. Now, I like to write all of these addition formulas always with A, B, A, B in that order. So then I remember that sin A minus B is sin cos minus cos sine, because I know the angle goes A, B, A, B. Equally, if we look at star up here, if I write it as A, B, A, B, sin A plus B is sin cos plus cos sine. Just remembering the angles go A, B, A, B. Okay, the next one is really neat. I'm going to swap in, I'll call this the kind of cross. I'm going to swap a for pi over 2 minus a. And it's really quite neat. So I'm going to swap a for pi over 2 minus a. So here we go. So I've got sine of pi over 2 minus a minus b equals sine of pi over 2 minus a cos b minus cos pi over 2 minus a sin b. And this is quite neat. Now we'll use the fact that on the right hand side is actually easier. We'll use the fact that sin pi over 2 minus a is the same as cos a. If you're not sure about that, have a look at the diagrams, go on to Desmos, and you can sketch sin pi over 2 minus x, or think about transformations. And we equally know that cos of pi over 2 minus a is cos a. So the right hand side comes out quite nicely to cos A, cos B, sorry, cos of pi over 2 minus A is of course sine A. and sine B. Now, the left-hand side's a bit trickier. I'm going to factor out the negative, so I have an a plus b there. Now, what I'm going to do is think of this as an x, like an angle x. I've actually got sine of pi over 2 minus x. Now, sine of pi over 2 minus x is clearly, I'll just do a little bit on the side here, sine of pi over 2 minus x, we know again from identities, is cos x. Well, but I've let x equals a plus b. So I've actually generated a formula for cosine a plus b. And then I've got my new formula, cos a plus b is cos minus sine. Again, writing a and b in order. And I've generated my third formula. To get a formula for cos a minus b, it's as simple as swapping again the b for a minus b. So I'm just going to go straight ahead and do that. So we've got cos a, cos of minus b, minus sine of a, sine of minus b. I'm going to use again the fact that cos of minus b is cos b because it's an even function, and I'm going to use the fact that sine of minus b is minus sine b. Minus times the minus is going to make a plus. We'll just do that in our heads. You can write it out fully if you want, and I get the fourth formula. Cos a minus b equals cos a cos b plus sine a sine b. Okay, now let's do tan a plus b. So if we look at tan a plus b, I'm going to write that as sine a plus b over cos a plus b. And what I've got on my next line is I'm actually going to write the sine a plus b formula. So that's sine a cos b plus cos a sine b over cos minus sine. So cos a cos b minus sine a sine b. Now I want to make this equal to 1 because I want tan a and tan b in my formula. So I'm going to divide the top and bottom by cos a cos b. I'm just going to pause it quickly to show. Okay, so what you can see now is I've divided the top of the fraction by cos a cos b, both terms, and the bottom of the fraction by cos a cos b. And nice things will happen. So that's all I've done. So let's see what happens now. Well, sine a over cos a on the top there simplifies to tan a. The cos b over cos b cancel. Cos a over cos a cancels. Sine b over cos b is tan b. And this is creating the tan a's and b's I wanted. Cos a over cos a is 1. Cancel. Cos b over cos b is 1. That clearly is a 1. Sine a over cos a here is a tan a. And a sine b over cos b is a tan b. And we've created our formula for tan a plus b. Wasn't that nice? So there it is. So to get our final formula, tan a minus b, we just swap as before the b for a minus b. So tan a plus tan of minus b over 1 minus tan a tan of minus b. I'm going to use the fact that tan of b is an odd function, so tan of minus b is minus tan b, and we'll end up with our final formula for tan a minus b, which is going to be tan a. Tan of minus b here is minus tan b because tan is an odd function, 1. And then tan of minus b here is going to be minus tan b, and the minus times a minus makes a positive, so it would be 1 plus tan a tan b, and we've got our 6th formula, and there we have it. So I hope you enjoyed that. They're neat proofs. Try them yourself. Remember, watching mathematics is one thing. Doing it yourself is good. See if you can prove all of these formulas. If you like this video, please make any suggestions and watch some of my other ones. Thank you very much.